Hello and welcome to my presentation about electron configuration on the periodic table. Starting off with the first block of elements, so we're going to be categorizing these elements into blocks, and the blocks are sorted down to what type of orbital they fill, so S, P, D, or F orbitals. We're going to start with S block elements, and these normally fill group 1 and group 2. But if you look at the periodic table and you just look at group 1 and group 2, you're going to notice something a little bit strange, and that is that you won't see helium because helium is a noble gas. It is located in group 18, but it is still considered to be inside of the S block because if you go look at its electron configuration, it is 1s2. Therefore, it should be in the S block. I photoshopped it right here into the S block just so you can see. Uh, and some interesting properties for the S block is that, well, the first group is very reactive and the second group is less reactive because their orbitals have been filled, so they do not want to lose or gain electrons. Next, we have the D block elements. So the D block elements fill up the transitional metals and just the transitional metals. And you might think that in the third energy level, so let's take like zinc for example, you might think, okay, I'll do 3s2 3p6 and then I'll have 3d10, right? Well, not quite. What you have to do first is you have to go and fill those s orbitals, not the third level, the third energy level, but the fourth energy level one, so the energy level after. So first 4s2 will be filled, and then we'll do 3d1, 3d2, 3d3, and onwards. So that's very interesting. And there's another important thing you should know is that chromium and copper have some special properties, and those are when you're filling up the electron configuration, what you'll think you're gonna do is, okay, so chromium has 4, right? So 4s2, 3d4, right? But no, the 3D orbital has 5 suborbitals, and those suborbitals will not be filled with 4 because they're 5. Will have a strong. Really wants to give that 4 the second element in 4s. It's not the element, sorry, the electron to the 3D orbitals, so it will become 4s1 3d5. That's for chromium, and then manganese, the next one, the next electron will not go to the d orbital, will go back to the s orbital and fill it back up. Same goes for copper, so very interesting properties, but these are only true for elements up to zirconium. After this, niobium and all these other elements do not follow these rules. Next, we have the F block elements. These are the lanthanoids and the actinoids, and you can see all of them below here. They're located on the bottom of the periodic table between group 3 and 4. And very interestingly, lanthanum and actinium um, are in the F block, but they do not fill the F orbital. I could not find a reason why, but I just wanted you to know that. Next is the P block elements. So the P block it has the most variety of elements. So at room temperature, many of these elements are gases, some are liquids, some are solids. You have metals, metalloids, and non-metals. So we have a little bit of everything in this block. And this fills up the P. So if you look, this is going to be P1, P2, P3, P4, P5, and P6. You can see right here, if you're going to use noble gas notation, the noble gases are here. And I wanted to include a full picture of the periodic table with all the blocks. So you can see here, they have actually moved the helium from here to right here. And that way, and now we know that is in group 2. And you can see all of them here. If you want to check out this table for yourself, look at the orbital notation for all of these, you can go to ptable.com and click on the electron periodic table and you will see this page. And with that being said, thanks for watching. I'll see you all in the next video.